Hey everyone, Leo is here. Another Johnson Lightning episode. I have Christophe here with me to talk to me about all things smart factory. It's going to be fun. Stay tuned. Hey everyone, Leo is here. Another Johnson Lightning episode. I have Christophe here with me to talk to me about all things smart factories. Super exciting topic. Christophe, how are you doing, my friend?
I'm doing great. Thank you, Leo.
Yeah, smart factories. I remember having multiple of these conversations in the past few weeks and months. But before we go and nerd out on all this stuff, Christophe, who you are, what is it that you do?
So I'm Christophe Cremon. I'm working at Avanade, venture between Accenture and Microsoft. I'm a senior solution architect and specialized in industry of the future.
Yeah, Christophe, I watched a previous episode that you did with Oliver. Big shout out to my boy Oliver in the IoT show. And I heard the conversation and I was like, you know what, this is a very interesting topic. And as I'm also kind of in the weeds of all this stuff, I thought that will be good to start having that conversation. You know, smart factories is something that at least been on my radar for a few months now, and also since I started working in the Agent Platform organization here in Microsoft. And it's a very interesting topic. It's an interesting topic to me because it's kind of a combination between the old and the new, and that's really where I was coming from to try to understand that. Help me understand, Christoph, like where you stand with this. Like, what is your background on this?
I started in November 2019 to help customers integrate OT systems, so operational technology and IT. And to be honest, it's kind of a nightmare for each and every client to have a convergence between the two types of people working in the shop floor and people securing the Azure cloud resources. And so we started with the automotive industry mainly
Mhm.
and utilities also.
Got it. So, talk to me about just kind of what's the landscape right now? I know that you have some visuals to share with me. I looked at those visuals before and I was like, okay, will be interesting to understand where you're coming from. Like, what is it that you're trying to convey here?
Yeah, so I'm coming from the IT, and I was not a specialist of OT.
Mm,
So what we can see in the difference between IT and OT is that the modernization of IT has occurred years ago, maybe 20 years ago. But in the OT side, it's still analogic and still, I would not say old school, but it's hard to have the same new fancy features and
mhm,
tools in the shop floor. So what I'm trying to do is being able to have a discussion between OT stakeholders and IT stakeholders in order to help people on the shop floor work with their machines with new technologies and not replace humans by robots, but put in the hands of operators AI tools, for example, intelligent applications that can help them achieve the goals of improving the production
mm.
quality, reducing the downtimes of the machines, and so on.
This world of old and new, like I mentioned, it's super interesting because none of us is coming, or I shouldn't say none of us, but a lot of us are not coming from that background of OT, right? I mean, I certainly never been in OT. I've never been like on a factory floor, operating heavy machinery or operating industrial assets and devices. So that's definitely an interesting thing to me. So talk to me for a second about like what's the experience for someone like you that is coming from that IT background and talking to customers that are in these factories and manufacturing space?
The main challenge, I would say, is that everything is happening in real time on the shop floor, so we
Mhm,
cannot rely, sorry, on batch systems taking data, aggregating data. We have to react in real time when there is an anomaly or an issue on the machine.
mhm,
So I had to deal with more and more edge solutions and not cloud solutions only. That was the difference between what I was doing before. Before we were able to ingest data in the cloud and process, let's say, 15 minutes after. There is no issue on real time. Here, the challenge is to be able to have the data processed, normalized, and contextualized at the edge. And the main challenge again is that every manufacturer is having his own way to describe the data of a machine. So that's why we need to to deal with, as I said, high frequency real-time data, and at the
Mm,
same time data that is not homogeneous. And so when we want to compare speed, downtime between machines that are not from the same manufacturer, we have
mm.
to deal with a data model that can be executed at the edge and at the same time queried in the cloud. That's the main challenge.
You know, I I can't even count at this point how many times we've been talking on this show in the context of this topic around the data. And I also mentioned this to a colleague of mine the other day, that none of the technologies really matters, in the sense that if you don't have the right data to do data analytics, if you don't have the right data to do business decisions that are based on that data, none of that matters. So I wanted to ask you, like, what are the biggest challenges that you're seeing right now you know with customers that are in this very heavy space of OT, of manufacturing, in the context of data? Like, is it the contextualization of the data? Is it the latency, the amount of data? What is it really that are the real challenges, the meats and bones here?
The main challenges that we are facing with our customers, or all customers are facing, is the three ones described here.
Mm,
First, we have to unify the data, so we have the data in one place. To be clear, you don't want to query thousands of tables and databases and so on, doing join in the queries and so on. So we want to have all the data, the industrial data from all the factories, from all the machines at
mhm,
one place that will be in the cloud, as you may know. And so that we are able to ingest at scale thousand, millions of messages an hour. That is the first step. But once the data is here, we don't want everything in one folder called factories. We
right.
want to also contextualize the data. Because if we are not able to contextualize the data, since the data is not generated by a human but by a machine, we are not able to understand if there is an issue, what is this data coming from, where is this data coming from. And so that's why we want to contextualize. It's the machine from a specific line in a specific area in the site of Austin in Texas, for example.
Yeah.
And so that we know that what is the machine that is talking to us or sending the message, and then we are able to act on the data. And the last step that is very important is to democratize the data.
Mm,
As you may know, every factory is separated in several lines, but each line is creating kind of a silo in terms of data. So the data is available for the operator next to the machine, but from one line to another, it's not really easy to share the data. So the idea here is to send the data to the cloud and then to be able to share, and with respect to the confidentiality and security, but to share to the stakeholders data that was siloed in the factory and in a line, and you have to physically go to the machine to see the data.
mhm,
When you are democratizing data, you are able to create KPIs, visuals, and understand as a human how are going your operations.
mhm. You know, just before we're switching here to the demo, I know that you have a very cool and awesome demo to show me. I got to share with you that I remember been doing electronics for so many years, right? And I remember the first time when you see, like, I used to kind of play around with microcontrollers, stuff like that. And I remember that the first time that you see what an MQ message look like, and what is the schema actually look like. So when you're saying, I can very much relate when you're saying, this data is generated by a machine, it's not generated by a human. And then you start seeing how a JSON schema looks like, and how data is coming from those microcontrollers in that example. It's kind of mind-boggling, because at the end of the day, you get so much data out of, and we're talking about factory floor, so we're talking about thousands of devices, that are running in just one facility or even in just one room, which is kind of insane. Um, and I remember the episode that we did a while back with John from the IoT Operations Product Group, when we are talking about the MQ broker. And I remember the demo that we started seeing that data that is coming from from simulated devices in that case, but what contextualizing data actually means, right? And it's just insane. It's just kind of crazy. And I definitely recommend to our viewers, if you ever wanted to understand what we say by contextualizing data, go hook a microcontroller, start playing with that, and connect it to an MQ broker and see what you're getting, and it will blow your mind, really. So definitely can relate to that. Christophe, I know that you have an awesome demo to show me. Show me the magic here.
Yeah, I have an awesome demo. Thank you for that. So what I've created is, as you said, contextualizing the data is a challenge, and we are seeing more and more often generative AI coming at work on a daily
Yeah.
basis. But we don't know exactly what to do with that. We are able to talk to an assistant that is smart, but here the goal was to use this assistant for an operator on the shop floor that does not know exactly where the data sits and does need to improve the production quality, understand what is the downtime of a machine, understand who is working in a specific line as an operator, and they want to reach him because of a machine that is down, for example. So I created a demo relying on three components. And in this scenario, it's a car manufacturer that is
Hmm.
manufacturing electrical vehicles with four types of products. So one that is a car, so two models of car actually, one model of truck, and one model of battery. I know that I may have be able to add more battery models, but to simplify the scenario, I have four different models and products to be produced. And the goal here is, I don't know exactly as an operator where is the data. Is it in a database or a specific application? I just want to ask to my assistant on the shop floor, um, in a natural language, some questions that are very simple. But behind, you will see that the assistant is able to do the queries for me and retrieve the data as an expert, as a database expert would do instead of the assistant.
Hmm. Very cool.
In terms of components, so I'm showing here what a typical solution looks like. So at the edge, you have the industrial assets that are producing data, mainly automatically, without the knowledge of, without being connected to internet. They are doing producing messages from telemetry from the machines. Then we have the data plane. So the idea here is to put a solution, can be a gateway attached to be installed in a factory, and where we can ingest the data from the industrial machines. And once the data is processed and ingested at edge, the idea here is to send the data to the cloud, because we are not able to store for a long time, all along the year, all the messages from all the machine. So the idea is to store the data for historization in the cloud, and that will allow also the training of AI models that can be trained on historical data and executed at the edge. So the inference at the edge. But
Hmm.
on top of the data that is in the cloud, I created a Gen AI agent that will be able to query for me the data and retrieve the results really easily. But in the Microsoft world, here I will expose the solutions that I developed and I deployed. Sorry. So the first, for the edge data plane, I'm relying on Azure IT Operations. That is a product that is today in public preview, and that is able to query, ingest, process, contextualize the data at edge at scale in real time using MQTT broker. And then with data flows that are a way to describe the flow of a data, we can enrich data at the edge with specific data sets that are only available at the edge. That is really important, because sometimes we only have the message from the machine, but we want to contextualize and enrich this machine is managed by this operator and what is the shift of this operator. And then with the data flow, there is another option that we can activate, is to send the data to the cloud and then in the cloud to continue the process. If we want to continue the enrichment, having data from a directory that is only available in the cloud, to have the phone number, the mail address of the operator, that will be from data only available in the cloud. So in the solution I created is how to deploy Azure IoT operations, a simulator to send the data in this simulator, in the Azure IoT operations component, sorry. In Microsoft Fabric, that is in the cloud, processing the data. As I said, there is one processing at the edge and one processing in the cloud. So we have multiple solutions in
Mhm.
Microsoft Fabric, and I'm highlighting here the ones that I use in the demo. And then once the data has been ingested, enriched at edge, ingested, enriched in the cloud, I'm able to query the data using the GenAI assistant, and with natural language, asking if how many products are we producing today, what is the yield of the machines, information of about the operators, and so on. So this is the full schema explaining the flow of the data from the edge to the cloud. I'm also following what we call a medallion architecture. And the
Mhm.
goal here is to move from, as an alchemist, from bronze to silver to gold.
Mhm.
Bronze being the raw data. Silver is the data that you can enrich with meaningful data that you can have at the edge. We all know that in factories, we also have MES, so manufacturing execution systems. So you can enrich the data coming from the telemetry with a production order, work order, for example, and then sending the data to the cloud to have the gold data, from silver to gold,
Mhm.
using Microsoft Fabric for this process.
You know, after such a thorough explanation, happy to see excited to see the demo. I think that the one comment that I will say here is that it's very interesting to start seeing these kind of generative AI workflows and solutions that are coming on top of data. We started seeing this on data that is just data that is already sitting in the cloud after it graduated to this gold phase according to the medallion architecture, but also how you're actually querying data that is still local at the edge, because that's something that is also important. So definitely, a lot of cool stuff. Show me the demo, Christophe. I'm
Yeah.
excited to see this.
Okay. So for the demo, just to explain what we are doing, to explain the magic, I'm leveraging the semantic kernel here, and the semantic kernel is a project led by Microsoft to help developer to basically talk to a LLM. So I have a Python code running on my machine. This code is able to connect to Azure OpenAI. So all the data is secured. I'm not training ChatGPT, OpenAI public application. I'm on my own tenant. And with my LLM, I will just ask him to create the query for me, but not to execute the query. So the data is not sent to the LLM. That is really important. It is just the LLM model is guessing what is the query to be executed, and then the Python application will execute the actual query, and then will send the results. So
Mhm.
I can show you here what is going on. So I have pre-populated questions so that I'm not typing the text every time.
Yeah.
So for example, I want to know what are the products that I am manufacturing in my different factories, and at which sites I am producing them. So I will just send this text as a question, and then the model will query the data in my database and send back the data frame. So that is really easy as an experience for a user, because I don't need to go to the database, query different tables, and retrieve the results by myself. I can do the same for the yield. I want to calculate the yield for this month for my machines based on the total number of units I have produced and the total good units I have produced. And here I am able to have the yield percentage
Mhm.
in less than 1 minute. It's a joke, but just to show that I'm able to have multiple queries imbricated in the backend. I can show you an example of this query. So my basic question of the yield, you see that the query can be really complex. And
Yeah.
since it's a database that is in Microsoft Fabric, that is a Custo database, uh, I'm not a Custo expert, but my LLM model is able to create the query for me, retrieve the results, and then I'm able to have the information in my application. It's a multi-language, so leveraging GPT-4o again in Azure OpenAI, so in my own tenant. I'm able to ask the same questions in Spanish if I want.
Mhm.
So here I'm just asking, this is the demo god that is not here with me. Every time I'm having some, not as hallucination, but I will read you the query here. I want to know what is the phone number and mail address of Steve Harris in a specific factory in Austin. And here I'm able to have the information. I will try the same with the Chinese question. So here is, I want to have the maintenance date and status of my different equipments, and I'm able to have the results in less than 5 seconds in my interface.
This is a very cool demo, Christoph. And as we're kind of wrapping up the episode here, I think that one of the things that is very interesting in terms of use cases that we're starting to see is how you're actually using generative AI on top of this type of data, right? Coming from factory floors or even retail, the retail industry, we see that a lot as well. Energy sector is what is it that you can do with the data that is still local? And that's what I mean when I'm saying like this hybrid model, when you have data that is already in the cloud and you can leverage things like OpenAI in, like you did in your case, the OpenAI integration, or also data that is still local, so you can use, for example, things like VectorDB in order to to add the doc or to have documents that are stored in a local database, and then for the LLM or the SLM to query that data. So that's kind of interesting, that you're showing this, and it kind of see how the industry and the people that are working on these type of projects are also starting to progress with the technology of that.
Yeah, exactly. There are two implementations, as you said. If the data sits in the cloud, then you have to have your assistant in the cloud to create the data, for sure. But you
Yeah.
can have the same with what we see now, SLM, so a small language model
Yeah.
against large language model. Because I don't know if you are aware, but when you want to have a specific agent in the factory, you don't have to rely on a ChatGPT that
Yep.
knows the encyclopedia of everything. So yeah,
Right.
this is a second implementation where you can have a specific dedicated assistant that is leveraging only small subset of features of the LLM, and that I think that is the future
Yeah.
in terms of implementation, to have everything at edge running locally, but you have to develop the contextualization of
Right.
both the data and the agent to make it work.
Yeah. I think that you're definitely gonna be excited about some of the things, Christoph, that we're coming up with next month at Ignite. Christoph, I wanted to say thank you so much for joining me for a cool demo, for a cool presentation, and a very interesting topic. Really, such an interesting topic. I'm really deep into the rabbit hole for this, and I feel like a complete knob, which is like, to me, that's really where I want to be. Like, for me, not knowing all this stuff and learning every day about new schemas and new way for SLMs to query data and different models, it's just mind boggling, and so much fun to be in that space. For the Jumpstart audience, thank you so much for joining us. We're going to see you in the next one. Make sure to like, subscribe, and looking forward really to see you in the next one. Bye, everyone.